Okay, so welcome everyone to today's session where we are going to talk about 2D arrays. Okay, now so far we have done arrays, right? Rather, the better way to say that is 1D array. Okay, because everything has been in one single line, or rather just one dimension, which is or one axis, which is along the x-axis, right? Now what we are starting with is, or now what we are understanding is, what if the data is two-dimensional, right? What if the data is spread in a matrix or a grid like a structure, okay? The data is sort of like this, right? What if the data is in this kind of like a format? Okay, so those kind of arrays which spread across both x and y axis are known as two-dimensional arrays, which is going to be the focus of the session, right? If you try to extrapolate this thought and make a 3D cuboid or cube like a structure and introduce z-axis as well, then that will go into multi-dimensional arrays or three-dimensional arrays, okay? That is one way to kind of represent 2D arrays. In a simpler way, what you can also say is a 2D array is an array of array, right? For example, when earlier you used to create an array of strings, right? So that means you have an array and at every position you are basically storing a string, right? When I say it is an array of arrays, right, what that mean is that over here there is an array, right, and at every index of this array we have another array. So here we have just stored the address of another array, right? And at every index, what you have is an address of another array. And that kind of makes it a 2D array, kind of like a structure. Rotate it a little 90 degree and that will give a better representation. That let's say if this is an array, at every index, you have another array. Let's say at every index, you have another array of same rows. Right? And what you see now is nothing but a 2D array. So an array of arrays can also be considered as a 2D array. Okay? And the syntax is very simple. If I do int a new int 3 and 4, okay, over here we have created a two-dimensional array, so that two square brackets, and I have given it the name a. It is again of homogeneous type, so it can only take up integer values, right? And this kind of an array is basically going to have 3 rows and it is going to have 4 columns. So in total, it can hold 12 elements, right? And what does it look like is something like this. I said 3 rows, so 1 row, 2 row, 3 row. In terms of indexing, this is row 0, because again for 0 based indexing, row 1, row 2. And I said 4 columns. Column 0, column 1, column 2, column 3. All right, this is what it basically is, right? This is how you define it. And let's say if you want to access a particular value, right, of this particular array, how do you used to do in one single array? They're used to, let's say you have to access this value, right? And this was at index 3. So you used to do a of 3. Okay. Here also it's quite similar. Let's say if I want to access this value, I will do a of, first you mention the row 1 and then you mention the column. So this will kind of uniquely identify each and every cell over here. So this overall is called like a matrix or a grid, like the common terminology that is used, right? And every single part of it is known as a cell. So this is basically A of 0, 0, right? Let's say this is basically A of 0, 2. What do you think this will be? Right? If this is a 0, 0, if this is a 0, 2 or 0 square brackets 2, this is going to be a of 2 and 1. Okay. Similarly, this is going to be a of 1 and 3. I will show for all only now. 0, 1, a 0, 3, a 1, 0, a 1, 1. A first always the row, then the column. Over here, right? And as you can see, it can hold a maximum of 12 elements, right? Always remember, Java uses zero-based indexing. That is why indexing of arrays and always starts with 0 and not 1. Okay. Similarly, let's say, although we are not going to go deep into it, but let's say if you do want to future create a 3D array, so I think you get the idea now how to do that. Yeah, this is 2, 2. And this will be, let's say, what is along, how many elements along the x-axis, how many along the y-axis, and how many along the z-axis. Okay, so here data is basically a 3D array that can hold a maximum of 24 elements over here, which is 3 into 4 into 2 elements, and all of them have to be of the type string. Okay. So this is how you actually create it. Let's actually see a little bit of demo as well. To understand this in detail. Okay, over here. So when I make an array, 2D array like this, right, it will basically allocate 12 cells to me, but all of them will be initially empty, right? Another way of how you could do by having some or a few default value is something like this, like we do it in 1D array as well. Let's say I call it A1. Over here, let's say it is supposed to have 3 rows and 2 columns, 1, 2, 3, 4, 5, 6. Okay, so sort of you can initialize a 2D array like this as well. Okay, simple example over here. Now let's try out a few things which are again very important from a conceptual point of view. Let's assume, or you have to predict, what will be the output if I basically do this. So let's try to run this to see what the output will be. Should be a little predictable now that 1D arrays are done. Okay, and you can see what happened over here, right? If I enlarge this a little bit, I have 2 square brackets denoting that what you're trying to print is basically a 2D array. It is an integer 2D array, hence the I over here at the rate and then the address of the array where this 2D array is basically created, right? That's what basically happens when I do this. Now, now that you have answered this, now think about what will happen if I do this. what could be the output if I basically print. Okay, so to know the answer for this, we need to kind of go back to what we just understood, right? Always remember that when I say 2D array of row 3 and column 4, what exactly it means is that I have a single array, okay, which has the indexing 0, 1 and 2. Okay, simple as that. And at every index, I have another array of size 4. Okay, and here we are basically storing the addresses where all these arrays are located. So if I print this now, what it is actually giving me is the address of those 3 arrays which are located at these positions. Okay, now let's say you have this matrix A and you want to find out the total number of rows in this matrix. Okay, going back to this, what I can very clearly see is if I want to know the number of rows, I can just do arr.length. Correct? Because that will tell me the number of rows. Dot length. Now let's say I have to now also print. This will tell me the number of rows. Now I also want to know the number of columns. Okay, so what I will do is if I do ARR of 0, this will basically lead me to this array. Correct? The moment I do ARR of 0, it will lead me to this array. And then for this array, if I do dot length, will it not tell me the total number of columns? If I do ARR of 0, it will basically lead me to this array. And if I call dot length on this array, it will basically tell me the total number of columns, right? For a better visualization, always rotate this image by 90 degrees. The initial array is of size 3 and at every index what you have is arrays of size 4. Right? So if I do ARR of 0, if the indexing is 0, 1 and 2, that will lead me to this array. And if I do dot length on this, that will tell me the total number of columns. So if you ever want to find out the total number of columns, so just do ARR 0 dot length. That will tell you the total number of columns over here, which is 3 and 4, right? If you want to print a specific value, right, like I said, you follow the concept of the indexing which we just talked about. Let's say if I do A of 1 and 2, right, let's see what basically gets printed. Like you can see, the default value in an array is 0. For 2D arrays also, because it's just an array of array, it's also 0, right? Because initially my array 2D array is empty, nothing is really there, right? So when you will try to print any certain value, it will actually basically give you the output 0. So this is how you access the value. Similar to 1D array, for 2D arrays also, if you want to set a value, let's say I do 2, 3 over here, right? And let's say I put the value 100. This is how you simply go to the second index, the third value, and basically instead of 0 now, you put the value 100. Okay, and now if you will try to print this value, you will not get a 0, right? You should actually get the value at that position. Okay, so you can use this to set a value also. You can use this function to update a value as well, right? To basically understand how exactly it is working. Okay, so these are the basic things, very similar and relatable to the concept of arrays to actually understand how exactly it works, right? Now, let's say next thing is, how do you print all the values of the array? Okay, let's say now you want to take each and every value of the array and print it step by step. Let's take this array only. Okay, so what will happen is, for that I will require a loop. Let's say I add a bunch of elements over here, 7, 8, 9. Okay, now let's say I have to print this all the elements of this 2D array. Okay, what I will do is I will take 2 loops. Okay, now if I really now go back how internally it's being implemented, it's like this. There is an array, right? This is basically pointing to this, pointing to this, pointing to this, right? So first I will go to each and every row, and for every row then I will print the columns. Okay, now I will run a for loop. I is equal to 0. I is less than, what is the length of this array? What is the length of original array? 3, right? But the indexing will run from 0, 1, 2. So it will be ARR dot length. Correct? So now this loop will only run from I of 0, I of 1 and I of 2, right? Because ARR dot length is 3, right? Now let's say you start with I is equal to 0 over here, right? You are at I is equal to 0, right? That means you are pointing to this row. Okay, now for this row you have to print all the values of this row. What you will do is you will do for j is equal to 0, j is less than ARR of 0 dot length, which is the total number of columns. Then you do j plus plus. So it's like I is over here right now. Okay, I is over here right now, and then I start a pointer j. Okay, now initially I is equal to 0 and j is also equal to 0. So this is ARR of I and j that you will print. Okay, because of which 1 will get printed. Now internal loop will finish first. J is equal to 1, j is equal to 0, j will be incremented to 1, right? And what is at this 0, 1? It is 2. So printed. Now increment the value of j again. Okay, and make it point over here. Now at this point you are pointing at 0, 2, which is the value 7. Now you make j is equal to 3. Okay, but in this case what will happen is this condition is violated. J is not less than ARR of 0 dot length, which is the total number of columns, which is 3. J is equal to 3 and ARR 0 dot length is also 3. So in that case this loop is completed. You come back to the original loop and you increment the value of I. Okay, and then again what will happen is the moment you do increment the value of I is equal to 1, the value of j again starts with 0. So it comes over here. Now I is 1, j is 0. So the value that is printed is 3. Okay, now the value of j will be incremented. J will come over here. So you will print the value at 1, 2, which is going to be 4. And then j increments further. It is 1, 2. Then it is the value 8. Now at this point this loop will again end. The value of I will be incremented, right? And sort of you will now come to this row and then start printing the values. Okay, I hope everyone understands how this will work. Let's see a quick demo as well. For int I is equal to 0, I is less than a1 dot length, I plus plus. For int j is equal to 0, j is less than a1 0 dot length. Because for every row we go to every column of every row, right? Now over here what will happen is you will do a1 I and j. Okay, so in this case, what will happen is when you will try to print it, it should print all the values one by one. Okay, if you don't want to print all the values all again in new lines, what you could also do is that you could do this, like for every row, it should go in the same row. So I have not added ln, but the moment you finish a row, then you go to the next line. So this will just change the way in which the output is printed. Okay. So if you print output this way, it kind of gives you a better visualization of, where a row is ending on which element and when the new row is starting, right? So this is what the basic concept is related to 2D arrays and how you can perform basic functions over here related to it, right? This is one way of using a very typical for loop over here, which we have been doing, right? What you could also do over here is you could do this, right? Or you could use an enhanced loop as well. So every row or every value of the array A is an array, right? Then you go inside this array also. Okay, and you can do this. Okay, this way you can like make it slightly more optimized, not bother about variables a lot, right? And you are automatically able to take care of it. Okay, so you can see in this array, because we are printing the array A, let's print A1 for even the correct answer. You can see over here the values are printed. Okay, and this is how you can basically take a 2D array, right, and print all of its values. Akshat, I'm doing that because I've not really taught the concept of jagged arrays and unequal arrays so far. Okay, I will teach this after that and then you will understand. Clear to everyone? I hope it makes sense to understand how exactly a simple 2D array works, right? And what are the related functionalities related to it. Great. Now, let's move to the next part, right? So far, what you will see is that the examples that I took, right, to create a 2D array were mostly either like a square kind of a structure, right? Or they were rectangle. Okay, where you have unequal number of rows and columns, right? You will see this example was kind of like a rectangular matrix, right? And this example was sort of like a square matrix, right? In Java, what you could also do is, because of the functionality that we really understood 2D arrays in Java as an array of array, what you could also do is you could also make jagged arrays. Or I would say, rather, the better term is jagged 2D arrays, okay, in the concept of Java, okay. What does that really mean is that for every particular row, right, you could have unequal number of columns, okay. For example, if I do this, int ARR or int ARR is equal to 2 and like this. Okay, so remember, this is very much possible in the concept of Java specifically. Okay, what I could do is I will say that it is an array of arrays, right? I will say that this is an array of arrays, right? But I will not define the number of columns over here. Okay, if I will put a value 4 over here, then it will kind of constrain us by the fact that every row of the ARR array will have another array which has to have 4 columns only, right? So that will kind of lead us either to a square or a rectangular matrix. Okay, in Java, what you could do is you can just define the array and you could just define the number of rows and not tell the number of columns. Okay, but the vice versa is not true. Like you cannot do this, that you have just defined the number of columns and you've not told the number of rows. Okay, this will throw you an error, right? But the upper part will not, right? You can actually make a 2D arrays in which you've just told the number of rows. Okay, so what it will do is, it will basically, let's say if I do this, let's say I mentioned 3 over here, what it will do is it will just initialize an array, right? An empty array with null values, right? But it has to have the number of rows over here, right? Now, like I said, the concept of jagged array means you have unequal number of columns. Okay, so what you could do over here is, you could say that at ARR of 0, what you do is new int 4. Okay, which is possible. I'll explain and I'll show you what does that mean, and I think you will understand yourself as well. Let's say I do this and I do this. Okay, this is invalid because for an array of size 3, it doesn't make sense to have the ARR of 3 value. Okay, it will throw an error over here because it is index out of bound. But what I did over here is I said at ARR of 0, create another array with 4, I would say, indexes or 4 values. So what it will do is it will basically do this 0, 1, 2, 3. Okay. Now if I do ARR of 1 new int 2, this will basically do this 0, 1. And then let's say if I do ARR of 2 new int 5, it will do something like this. Okay, so this is possible. This is called as a jagged array, which is considered to have unequal number of columns in a particular matrix. Try to rotate it 90 degrees and that will give you a impression. Okay, I can just maybe, no, it will not give me, I don't think it will give me any sort of rotation like that. Okay, yeah, but the idea being that if you will see over here, it has unequal number of rows and columns. Okay, so all the functions which were just applicable over here may not be completely applicable over here. Okay, now for jagged arrays, if you will see over here, now if I have to find out the number of rows, that is still the same, right? For finding out the number of rows, it is still the same part. You could just do ARR.length, right? But now in this case, the number of columns are not constant for every row, right? So in that case, you can't just put ARR of 0, right? You'll have to put different values like these in order to be able to find out the number of columns in a particular row, because every row is different, right? So the columns part will not be completely just that. It's if you just take ARR of 0, that will not be applicable for all. Here, the number of columns that were there for the first row was the same for every row as well. Okay, so that it kind of worked over here. But if you have the jagged array kind of like a structure, it won't work like that. Okay, so remember that in terms of setting, it doesn't matter if it's a jagged array or not. Anyway, you need to know the number of rows and columns, then only it works that way, right? For example, if I am at this is nothing but 1, 1, right? And if I am at this, it is A, the row is 2, the value is 4, right? So the setting and the getting part is same, just that the number of columns changes. And based on that, the for loop will also be modified over here. Okay. Here again, we were assuming that always the number of columns are constant, right? That is why we were just doing ARR.length. What you will do is, if let's say you want to print the values of a jagged array, what you will do is here, the number of rows will remain the same, right? So you can just do A1.length, right? But the number of columns, you can't use 0 over here because all the rows columns are not same. So if let's say you are on the 0th row, you have to consider that row and the number of columns of that row. If I is equal to 1, you have to do that. You can try this as well, that this will not work and it will eventually throw you an error. What was this array? ARR. Okay, if I do this and let's this change this also. Okay, okay, you can see this works fine. If the number of rows is 3, the number of columns separately for each and every row is printed, right? But what will happen is if you will do ARR of 0, what it will assume is that for every row, the number of columns are same. For the first row, right, the number of columns were 4, and it assumed that here also it will be 4 columns, but it did not have 4 columns. That's why it just printed the first 2 values and after that threw you an error, right? To do this in a better way, ideally you should be using the number of columns for each and every row and then trying to print it. And then you can see the representation is absolutely correct. Okay, so this is the concept of jagged arrays. Again, they do find use case in some scenarios where you want to save space and you're already sure what the number of, I would say, columns in each and every row is. If you already know that, feel free to save space and not actually, go ahead and create, I would say, a 2D array and then save spaces if you use rectangular or square, right? Save space, create a jagged array, so that you don't actually use space which you don't require. Okay, and this completely forms the theoretical part of understanding the concept of 2D arrays.